We are going to continue with chapter 3, tools with plastic analysis and design. We already talked about the concept of the virtual work, and now you understand the virtual work and how it application. And, today we are going to talk about some more about the application of the virtual work concept. Okay. Let me make a review on the 5 major applications of the virtual work. As we already mentioned, the virtual work can be used to obtain the geometrical relationship of mechanism motion by assuming the appropriate equilibrium set. The second application is to make a moment check for a given mechanism by assuming the appropriate displacement sets. The third application is prove the uniqueness, unsafe, and safe theorems. And the fourth application is to obtain about bounding solution, including upper bound solution and lower bound solution. And the last application of the virtual work is to calculate the deflection and collapse load. Okay. Then now I'm going to show you one by one the application of the virtual work. First, the virtual work can be applied to obtain a geometrical relationship. Now let's consider a structure like this. We have a structure, let's say A, and here's B, and C, and D, A, B, C, D, okay? And we assume that this displacement set like this, okay? The dotted line is assumption of displacement set. So with this displacement set, we have the geometrical relation, geometrical set. So let's say the rotation is theta 1 and theta 2 here and theta 3. And remember the dimension of each dimension. So the height is 20. So the unit is not important. So you can assume the unit, okay, inch or something, feet, inch, it's okay. So the height here is 25 unit, and here's 5 from AB, horizontal length, this distance. BC is 10 and CD 10, and so on. Problem now is we have to determine the relationship between theta 1, theta 2, and theta 3. How to determine the relationship between them. That is our task. And now we use virtual work concept to determine the relationship between them. Okay. So to do so, first we can assume the equilibrium set. Okay, equilibrium set. First, we assume the equilibrium set 1 for determining the relationship between theta 1 and theta 2. Okay, so to do so, we generate the equilibrium set by simply applying a unit internal force in member BC. So let's say here's B, okay, and C. We apply a unit internal force inside BC units, okay. So by apply this unit force, then we can determine reaction at A and at D. It's very simple, right? You can determine because this is 20, then the reaction force here, the reaction moment is 20, and the horizontal reaction is 1, equal to 1 for AB. And for C, sorry, here is D, okay. And for CD, similar, we have the reaction moment is 25 because the height here is 25. And the horizontal reaction is 1. So now we have equilibrium set for this assumption. And remember this equilibrium set and combining with the displacement set, then we can determine the relationship between theta 1 and theta 2. Now, here we go. Now the originally we have displacement set. We already know, right? It is original set, original displacement set. Then now we have to determine the relationship between theta 1 and theta 2. And it is equilibrium set number 1. Okay, equilibrium set number 1. Now using this relationship, we have displacement set and equilibrium set. Now we make the rotor work equation. Let's say the external work equal to internal work. So what is external work and what is internal work? In internal work equal to 0. Okay, external work, we don't have any load. Okay, external force, no. Then external work equal to 0, so at 0. Internal work. Internal work, now we have theta 1 multiplied by moment here is 20. So we have theta 1 multiplied by 20. This is displacement set and this is equilibrium set. And theta 2 and multiply by moment here is 25. Please remember the sign convention. Okay, a sign convention. And by considering the sign convention of the displacement and the equilibrium set, then we have it is plus and this is minus, or this is minus and this is plus. So please check by yourself. But for this development, then we have to consider also the sign convention. And now, very simple, we can determine the relationship between theta 1 and theta 2. Theta 1 equal to 5/4 of theta 2. Very simple, right? Next is relationship maybe between theta 2 and theta 3, or theta 1 and theta 3. Okay, so you can make a relationship between theta 1 and theta 3, and because you have theta 1 and theta 2 relationship, then you can make its relationship. So now we try to make a relationship between theta 1 and theta 2 and theta 3. Okay, theta 2 and theta 3. For this relationship, we assume the equilibrium set. Let's say this is equilibrium set number 2. With this equilibrium set, we generate the equilibrium set by first applying an internal compression force in member C and D. Okay, we apply the compression force in member C and D. Remember, this force can be divided into different components: the vertical component and the horizontal component. Okay, so let's say this force can be divided into two components, vertical and horizontal. So to ensure this slope of the CD member, then we can use here 10 and 25. Or you can use this one, then this one is 2.5. Okay, 2.5. Okay, but no problem. And now we try 10 and 25. Then, by this force, we can determine a reaction force or internal force in other member. Okay, the external force, including external moment and reaction in other member. So for the member BC, the moment here is 25. Okay, 250. And the reaction here, you can calculate, okay, the force here, or you can use it is 10, and maybe here is 25, but compression, so it's like this, for example. Then you can determine this moment, and also you can determine the reaction here, 10, and the reaction here is 25, and also the reaction here is 10, and reaction here is 25. So because there's you can like this, okay, here is 10, here is 25. Okay, so we have equilibrium set now, equilibrium set. Now combining between the displacement set and this equilibrium set, it becomes, here, this equilibrium set, this displacement set with new assumption of equilibrium set. So let's say this is equilibrium set number 2. Okay, number 2. So again, applying the total work equation, internal work equal to external work, and again, what is external work. External work equal to 0, okay, and internal work equal to theta 1 multiplied by this. Sorry, here we make a relationship between theta 1 and theta 3, not theta 2, right? Theta 1 and theta 3, I'm sorry. So in the previous, we have to change theta 1 and theta 3. So theta 1 multiplied by 325 multiplied by theta 2 here, minus theta 3 multiplied by 250. Then considering the sign convention, we have minus here. You have to check the sign convention by yourself. Then finally we have theta 3 equal to this 30 divided by 10 of theta 1. So now we have relationship with theta 1 and theta 2, and here is theta 1 and theta 3, and you can make a relationship between theta 1, theta 2 and theta 3. Okay. So that is an application of the work on obtaining the geometrical relationship. Second is make moment check. Second application of the work is make moment check. Let's consider a photo frame like this. So the load P, C at the middle of the beam, and PC divided by 2, the half of PC, okay, half of PC at the top of the column, the left column. Remember, the dimension of the column is L divided by 2, and the length of the beam is L, and the load is the middle. So let's say here's A, and maybe B, and C, and C and D, something. Or here, maybe A, and maybe B here, and C, and D, and maybe E, whatever, C. Okay, so first we have to determine PCU, because using vector work method, and we can determine upper bound solution. Okay, upper bound solution. If our assumption is correct, then PC. But sometimes we don't know if the assumption is good, correct or not. Then it is PCU. And after that, we have to check the moment check to ensure that the solution is correct or not. So first step, determine the PCU. But our focusing is moment check. So you can do calculating the PCU by yourself, but I will introduce very briefly mechanism. First, we assume a mechanism like this. We assume the plastic hinge occur at the middle, at this point and this point. Okay, so if it's A and B, so E and C, E and D. Then we have mechanism like this. Using this mechanism, we have displacement set. Okay, so let's say here, this is 1 over 2 of L and theta, and this displacement is also half of L multiplied by theta. Then we have external work equal to internal work. External work equal to this one multiplied by this one, then plus this one multiplied by this one. Then we have external work. For internal work, we have MP here multiplied by this one, and MP here multiplied by this one, 4 MP and 4 MP theta. That is internal work. Then finally we have PCU equal to this one. Now we have to we do moment check by the assumption. Assume mechanism, we have MP here and MP here. But the problem is that we don't know MB. Then now we have to check MB. And the condition is MB should be smaller than or equal to MP. If this condition is satisfied, then our assumption is good. Okay, so how to do the moment check? Now we have this. So for moment check, we assume the displacement set. We assume the displacement set with beam mechanism. So let's say here, let's see. Now we can assume the new mechanism. It is dependent with the original mechanism. Okay, that is the very interesting point of the virtual work in doing the moment check. You can assume a different beam mechanism by doing the developing the virtual work equation like this. Then finally we have MB equal to MP over 3. It's smaller than MP, then okay, good. Okay, so remember this one. Okay, and now we can do the moment check with sway mechanism. This mechanism. Okay, so new let's say sway mechanism. We assume the displacement set like this is freely. Then again doing the virtual work equation, external work equal to internal work. Then this we have MB again equal to MP over 3. It's smaller than MP. Then it's good. Okay. So here again, the interesting point is that we can assume the different mechanism or with different displacement set. It is independent with the original mechanism to do the moment check. So it is very interesting point. It's like magic, right? Like magic. Because of this, we can assume a very simple mechanism. So let's say in the previous one, this mechanism is called beam mechanism. Very simple. So with beam mechanism, we can consider this part and this part only. This part only. Okay. Then we can develop this equation by on beam mechanism. And similarly, in this case, we assume the sway mechanism with or displacement set with sway mechanism. It is also simple. Okay, very simple. Then you can check, and it is so that the result is identical. Okay, the result is identical. That is another application of virtual work equation to make the moment check. So from now on, you can use this application of virtual work to do the moment check with independent displacement set. Okay,